Hello friends, we will now see one university question and answer for calculation of slope and deflection by using conjugate beam method. This question is for JNTU in the year June 2015. For calculation of slope and deflection, there are several methods such as Macaulay's method, Morse moment area method, conjugate beam method, strain energy method, unit load method, etc. But for each and every problem, some methods will be appropriate. Here the problem is chosen such that the conjugate beam method is very appropriate for this problem. The given beam is 5-meter span. It is loaded with 2-point loads, 25 kilonewton each, at a distance of 1 meter from either support. This is the beam 5-meter span with 2-point loads, 25 kilonewton here and 25 kilonewton here. A and B are the end supports, C and A are the loading points, E is the center point of the beam. Now we have to calculate slope at each end. That is, we have to calculate slope at A and B. We have to calculate theta A and theta B. And under the each load, that is, we have to calculate the slope under the load C. We have to calculate the slope under the load D. So we have to calculate theta C and theta D. Then what are the other points to be calculated? Deflection under each load and at center. That is, we have to calculate deflection at C, deflection at D, and deflection at E. Now let us see the further working of this beam. For the given beam and the applied loads, we have to first calculate the reactions. It is subjected to 2-point loads, 25 kilonewton each. So by virtue of symmetry, the reaction RA is equal to 25 kilonewton and RB is equal to 25 kilonewton. And what is the bending moment at C? Bending moment at C is 25 kilonewton into 1 meter. That is, MC is equal to 25 into 125 kilonewton meter. Similarly, what is bending moment at D? MD is equal to 25 into 125 kilonewton meter. And what about the bending moment between C and D? Bending moment at C and D remains constant because there is no load between the points C and D. And the shear force remains same between the points C and D. The shear force, 25 kilonewton acting upward due to the reaction, is balanced by the 25 kilonewton acting in the downward direction. Any point beyond C, the shear force is 0. Therefore, the bending moment remains constant between C and D. Now, for the given beam, we have to draw the conjugate beam. Given beam has a simple support A. Therefore, in the conjugate beam also, we should have a simple support at A. That is, we will call it as A dash. In the given beam B, we have one simple support. So, in the conjugate beam also, we will have one simple support at B dash. And what about the loading on the conjugate beam? The loading on the conjugate beam is 1 by EI times the bending moment diagram. The bending moment diagram is one triangle varying from 0 to 25 at C. 1 by EI times means 25 by EI. Similarly, on this side, we have the one triangular diagram for the bending moment diagram, that is 0 to 25 MD, and M by EI means 25 by EI. Bending moment remains constant between the points C and D. So here also the bending moment diagram remains same between C and D. So this is the 1 by EI times bending moment diagram. This happens to be the loading diagram for the conjugate beam. We have calculated the bending moment at various points A, C, D, B, etc. And 1 by EI times the bending moment diagram will become the loading diagram for the conjugate beam. And before that, let us convert the units for E and I. consistently with respect to the dimensions and the loads given. E is given as 2 into 10 power 5 Newton per millimeter square. To convert Newton to kilonewton, you have to divide it by 10 power 3. To convert millimeter square to meter square, you have to multiply it by 10 power 6. So it becomes 2 into 10 power 8 kilonewton per meter square. Moment of inertia is given as 1 into 10 power 8 millimeter power 4. To convert this to meter power 4, you have to divide it by 10 power 12. It becomes 1 into 10 power minus 4 meter power 4. Now, the loadings are in kilonewton, the dimensions are in meter. So, E is also consistently in kilonewton per meter square. Moment of inertia is also consistent with the other units, that is, it is converted into meter power 4. Now we have to calculate theta A. Now what is theta A as per the theorem? Theta A is the slope at A is equal to the shear force at the respective point of the conjugate beam. That is, theta A is equal to shear force at A dash. Slope is equal to shear force. That is the conjugate beam theorem. Theta A is the slope at A. That is equal to shear force at A dash. Now, what is shear force at A dash? It is nothing but equal to the reaction of the conjugate beam. The conjugate beam, what is the reaction? RA dash is equal to RB dash is equal to 1 by A is the common factor, take it outside. The reaction is contributed by the 2 triangular diagram and 1 rectangular diagram. The area of the triangle is 1 by 2 into 1 into 25 into 2. These are the 2 triangular loads. 1 by 2 into 1 into 25 into 2. Then what is the area of the rectangle? 25 into 3. This is the total load. Total load divided by 2 will give the reaction, that is equal to RA dash and RB dash. So it comes to 50 by EI. 50 by EI is the reaction RA dash and RB dash. Now we have already seen theta A is equal to shear force at A dash. That is RA. That means it is equal to 50 by EI. Theta A is equal to shear force at A dash is equal to 50 by EI. After substitution of the values of E and I, we are getting theta A as 0.0025 radians. If you convert this to degree, you multiply by 180 by pi, you will get this in degrees, 0.143 degrees. Similarly, theta B is equal to theta A by virtue of the symmetry is also equal to 0.143 degrees. Now we have to calculate theta C and theta D. That is the slope under the loads. Theta C is equal to the shear force at C dash. Theta C, slope. Slope is equal to shear force. Theta C is equal to shear force at C dash. Shear force at C dash is contributed by 2 components. One component is due to RA dash. The other component is due to this triangular load. RA dash into 1 meter. RA dash is 1 force and the other force is 1 by 2 into 1 into 25. That is of opposite side. So this is due to RA dash minus the triangular load 1 by 2 into 1 into 25. 1 by A is common. This comes to 37.5 divided by EI. After substitution of the values of E and I, we get this in radians. For converting this into degrees, you multiply this by 180 by 5, you will get this in degrees. So theta C, theta D has been calculated. Now we have to calculate the deflections at various points. Delta C. What is delta C? Delta C is equal to deflection at C. Deflection is equal to bending moment. That is the second theorem. First theorem is slope is equal to shear force. Second theorem is deflection is equal to bending moment. That is deflection at C is equal to bending moment at C dash. Deflection at C is equal to bending moment at C dash of the conjugate beam. Now, bending moment at C dash is contributed by two components. One is due to RA dash. For this, the lever arm is 1 meter. The other component is due to triangular load. That is equal to 1/2 into 1 into 25. Of course, EA is taken outside as common factor. The lever arm for this triangular load is 1/3 meter from point C dash. So we have written the value of bending moment at C dash here. 1/EI is taken outside. This bending moment is contributed by the reaction. This is the triangular load. 1/2 into 1 into 25. Opposite sign minus. Into is the lever arm 1/3 meter from C. This reduces to 45.833 divided by EI. On substitution of values of EI, we get this value, that is 0.00229 meters. Multiply this by 10 power 3, you get 2.29 millimeter. This is the deflection at C, which also happens to be deflection at D by virtue of the symmetry. Now we have to calculate the deflection at center. That is deflection at center means deflection at E. This is. So what is deflection? Deflection is equal to bending moment in the conjugate beam. Deflection at E is equal to bending moment at E dash in conjugate beam. Bending moment at E dash is contributed by three components. One is due to RA dash, that is RA dash into the lever arm is 1 meter plus the distance between C dash to E dash, that is 1.5 meter. So the lever arm for RA dash is 1 meter plus 1.5 meter, that is 2.5 meter. Then you have this triangular load 1/2 into 1 into 25. The lever arm is at a distance of 1/3 meter from C dash. That is 0.33 meter from C dash. But with respect to E dash, the lever arm is 1.5 meter plus 0.33. That is 1.83 meters. Then you have this half of the rectangular load. The magnitude of the load is 25 into 1.5. And this lever arm is at a distance of 1.5/2 with respect to E dash. All the three components have been written here for calculation of bending moment at E dash. This is due to reaction 50 by EI into the lever arm 1.4. Then you have triangular load downwards, negative sign. The load is 1/2 into 1 into 25. The lever arm is 1.5 plus 0.33, 1.833 meter minus half of the rectangular load. That is 1.5 into 25. The lever arm is 1.5/2, negative sign because it is downward load. It reduces to 73.96 divided by EI. On substitution, this comes to 0.0037 meter. Multiply this by 10 power 3. You get 3.7 millimeter. So this is the deflection at center, which is nothing but the bending moment and the conjugate beam. Delta E is equal to bending moment at E dash. Deflection is equal to bending moment. Deflection at E means bending moment at E dash. This is the conjugate beam theorem. Friends, beyond this also, lot of explanation might be required, and I request you to visit my website rgnsite.wordpress.com. In the Google search engine, if you type rgnsite.wordpress.com, you can visit my site. It contains 500 university questions and answers on various topics such as RCC design, steel design, strength of materials, structural analysis, volume 1, volume 2, including moment distribution method, matrix methods, etc. Beyond this, detailed questions and answers, lot of explanations in the form of one word questions and answers have been given. So those explanations and one word questions and answers will meet your requirements. Please visit rgnsite.wordpress.com and have a free download. The download is free for all the 5 subjects: RCC design, steel design, strength of materials, structural analysis 1 and 2, 500 university questions. Download is free. Visit this site, rgnsite.wordpress.com. Thank you.